I was really frustrated at seeing and knowing just how important the structural engineering community was to optimization, embodied carbon material use, but we weren't in any of the conversations.
Over the course of his 35-year career as a structural engineer and as the past president of the Seattle-based MKA Structural Engineers, Don Davies has guided the construction of numerous high-rise buildings around the world. But nearly 15 years ago, his focus started to shift after realizing how important structural engineers were to lowering the carbon impact of the built environment, yet they often weren't included in the conversation. So Don got curious. And that curiosity, in relative short order, led him to a tribe of like minded, intrepid individuals who would go on to co create several organizations and carbon calculating tools that have forever changed the industry. You've done so much in the world of carbon with being one of the founding members of the Carbon Leadership Forum and then subsequently building transparency, which launched Tally and EC3. But what first sparked your interest in carbon and carbon reduction strategies?
So why carbon? I'm a structural engineer, and at my core as an engineer, I love to solve problems. That's what got me into the profession and for what I wanted to do. Climate change, our impacts on the planet, that's the biggest problem we are facing these days. And so, as a structural engineer, I spend my time proportioning really large quantities of materials, concrete, steel, wood, on how we're going to use them to create our built environment. Huge, massive impact on our planet. Carbon is a way to tell a value and optimization story of how we can use materials smarter, and then how we can actually do a better job with those to create a built environment that's part of a solution, not just part of a problem.
Given that Carbon Leadership Forum you
Mhm.
co-created in 2009, that was quite some time ago when not a lot of people were talking about carbon. So what prompted that?
So, identified the problem. We overconsume our resources and wanting to do something about that. The Carbon Leadership Forum was really a group of like minded individuals came together initially in San Francisco to talk about this thing called life cycle analysis. How do we measure? How do we track? How do we use this information in decision making to make a better, um, more environmentally responsive built environment? I was fascinated with the idea, and it got me real curious because now here was a way to bring data to these conversations, to what was a non-data driven conversation. And here was a good group of people trying to work on this problem. Um, but when it started in San Francisco, but when it really took off was when one of my classmates from UC Berkeley, Kate Simonen, stopped being an architect and engineer in the Bay Area, moved to the University of Washington, and as a professor, but then really took over leadership of the Carbon Leadership Forum and really advanced that. And Kate was an amazing coalition builder, consensus builder, and an equally curious soul about trying to bring people together on how to solve and be part of a solution to these bigger problems of how do we use carbon in the built environment in a more responsible way.
And then how did that then morph into or birth the building transparency?
Building transparency was a almost a natural offshoot out of the origins of what Carbon Leadership Forum was trying to do. It it took us 10 years of talking about it and trying to understand this topic to be able to better act on it. But the idea of life cycle analysis and environmental product declarations, that was there from the beginning of CLF. We just didn't know how to do something with it effectively. Um, Building transparency was the confluence of a couple of things coming together. Microsoft was going to do a $2 billion campus redevelopment, and Skanska, as part of trying to get that project, pitched Microsoft that they wanted to use carbon and measure environmental product declarations for everything that went into the project, or as much as they could get into the project. And Microsoft is a data company, and they said, yes, let's do that. So now we had Skanska, we had Microsoft, and some really passionate people that were helping bring that together. It was the right timing to act on this. And so we created what was called the EC3 tool, or the Embodied Carbon Construction Calculator. And there was a group of people that came together to do that. Stacy Smedley, Phil Northcott, Kate Simon, and myself were the initial four working on it, but it was a whole coalition of getting industry to work on this together, but use this Microsoft project as a test bed to really expand and try to see how far we could use this. And it really touched a nerve with a lot of people and really just kind of took off from there.
I guess I'm having trouble putting the pieces of the puzzle together. So the CLF launched.
Carbon Leadership Forum launched in 2009 and was evolving as a think tank of how do we talk about carbon? How do we measure with carbon? How do we advance the ability to use this? Um, Out of the Carbon Leadership Forum came a group of people who decided to create this EC3 Embodied Carbon and Construction Calculator that we used for the Microsoft project. And then ultimately, we spun that tool and database out of Carbon Leadership Forum to be its own nonprofit that we call Building Transparency. So Building Transparency's origins came out of Carbon Leadership Forum as a tech-focused tool and database provider for allowing decision-making on carbon and on embodied carbon.
And then was that Microsoft project one of the first kind of use cases for
That
EC?
was absolutely the pilot. That was the use case. EPDs have been around. People have been experimenting on small projects, but the Microsoft project was a serious concerted effort to use it on a bigger scale and on a major project with major players. So the big thing about the Microsoft project, it wasn't the first to use EPDs, but it was simply just the scale. This was a $2 billion redevelopment, and Microsoft put it in their specifications into their RFPs for designers, for the contractors, that they needed to show their expertise on carbon. They needed to plan on using EPDs, and that was part of their procurement process. So no one had done it at the scale that Microsoft was going to do on the project. And anyone that wanted to work on that project, everyone got religion very quickly on what an EPD was and how we're going to use it. And we saw immediate gains in major ways. The entire concrete market in the Seattle area dropped its carbon footprint by almost 20% over 2 years from when we started asking the question for EPDs and then using that to inform a decision process. And it started with Microsoft, but that was like the tipping point that it scaled, and it really started being used on a lot of other projects. And there's other things that helped those carbon reductions happening, but basically there was a collective will to lean in, and people were jumping behind the bandwagon for that to happen.
That's amazing. Yeah, I guess when
Yeah.
you start measuring, it really opens your eyes to the impacts, and then you can use that as leverage to ask these manufacturers to reduce the carbon footprint.
One of our cores when we were starting this whole EC3 tool, I was using the terms, you can't manage what you don't measure, and people will value and they will compete on the data we do measure. And so asking these questions, especially at the time that you're making buying decisions, is a really powerful time to get people's attention and to ask questions. And that's really what EPDs and the use of EPDs are for. How do we compare like materials to pick who is the lower carbon provider when other things are similar, including costs? So it's how do we it helps us find the win-win scenarios where we can make more informed purchasing decisions. And it's that idea is timeless and is expandable to a lot of different locations and scales. And so BT, when we started, I think there were 800 EPDs across the country for ready-mix concrete that we put all into this one database called EC3. Today, there's over 160,000. Uh, so, I mean, just the expansion of this is just kind of a sign of how fast industry has jumped onto this topic and been willing to embrace this idea of measuring, managing. Uh, they want to be part of the conversation. And especially our hyperscalers like Microsoft, but frankly, like Google, like Amazon, like Meta, like Salesforce. There's other hyperscalers that are also have jumped into the same space and are using EPDs in these ways.
That's fascinating. And it seems like you in those early days were really able to grow building transparency to a pretty good critical mass. Um, and from what I understand, it was really by bringing this collective kind of diverse groups together. Um, how important was that, and how did you do that?
Microsoft and Skanska were really big names to be able to start EC3 in this conversation about. But one of the things I appreciated at that time is the prior engineering practice I was part of was working with a lot of different technology partners, building their headquarters buildings, building infrastructure for them. And what I saw was that the sustainability leads at Google, at Microsoft, at Amazon, they were all facing the same challenges in their organizations. And every one of them was an incredibly influential and powerful company, but they could be so much more influential if they actually were asking the same questions, working together in the same space. So one of the things we did is we took the leverage and the motivate and the momentum we were getting from the Microsoft project, but when we created Building Transparency, we got the sustainability leads at these other companies to come on and be our board of directors. So we quickly had this collaborative forum where the sustainability leads at Amazon, at Microsoft, at Meta, at Google could all be working together, asking the same questions, and then in their own organizations, um, asking for the information in the same way. Now, these are really competitive companies that compete all day long in a lot of different ways, but this was a place where collective action, by actually working together, made them stronger, gave them an ability to move an entire industry just because they were going to all speak with the same voice and make a common ask. And that is really was also part of the secret sauce that let building transparency scale. And it wasn't just me. There was multiple people involved in driving this along, but kind of building out that coalition and getting those hyperscalers, especially, all to speak in the same way and use EPDs in the same way is really what allowed us to really accelerate what we're doing today.
And many of those organizations are still involved today, right?
Oh, absolutely. In fact, we just had a board meeting this morning, and it's amazing to see that collaboration that still continues. We're friends because there's a common mission here to how do we move the built environment to a place where it's more of a solution and less of a problem to how we solve climate change. It's a place where we can all be working on it together.
From those early days of building transparency, how has the organization shifted? I know at one point you had to step back in as interim executive director, and but now I think you've gotten someone in that role. But how has the organization evolved over the years?
We created this nonprofit. It was a consensus-based collaborative effort. It took off and was more successful than some of our wildest dreams. It was like in many ways, um, job well done. But like anything, I kind of think of building transparency as like going through it. We just went through our teenage years. We had great success. We grew really, really fast, and we had some uh, good successes there. But we just went through a transition where we needed to change our executive director and kind of evolve from an origin story of where it just started to evolve to this mission-driven organization. How do we make this durable, lasting? How does it go longer? So I was the initial board chair, but really was trying to just be a supporter of the larger organization. But when this transition needed to happen, I stepped in to be the interim executive director, really just to be stability for this transition. take us through those teenage years to then bring in a new executive director that could help be the leader for building transparency to what comes next, which is Allison Kin-Bennett is now the new executive director of building transparency. And so I can now step back out of that role and let her run with it. And super exciting about her background and what she'll be able to bring to the future of this organization.
While Don may be turning the building transparency keys over to a new leader, his work in reducing carbon emissions isn't done. Several years ago, he and his wife, Joan Crooks, bought a commercial building in Seattle to serve as a living laboratory of sorts. Called Hubbard's Corner, it has allowed them to test novel materials and solutions to reduce the carbon impact of the built environment.
Spent 10, 15 years here helping Carbon Leadership Forum, building transparency, but was always with the primary focus of being president of a structural engineering firm, driving engineering practice forward. But my passion kept more and more driving to how do we act on carbon? Are we doing this in the most responsible way? Can we leverage these things in different ways? And call it curiosity, call it interest in trying to put things into practice. When I stepped back from what I was doing in my prior engineering practice, we bought a building and decided it's an adaptive reuse commercial project, but decided to put a bunch of these ideas we've been talking about into practice, not just as the engineer, but also as the owner to help drive decision making. And so we made this project a living laboratory, trying out new materials that we talk about and we get EPDs for, or talk about these next generation tools that maybe aren't in the market yet, but we wanted to understand how hard would it be to actually use those. And my thought was it should be a lot easier than we make it out to be if there's a collective will to try. And so our project, Hubbard's Corner Living Laboratory, was an effort to just do that. It was an opportunity to, in a risk managed way, experiment with these new materials and to answer a couple of really big questions I'd been struggling with at Carbon Leadership Forum and in just this whole carbon ecosystem in general. There's a lot of conversation about carbon neutral, carbon negative materials, carbon negative buildings. And I wanted to see how close can we actually get to a carbon neutral or carbon negative building if we're actually real with the numbers. Not if we actually measure everything, we try to totally understand our impacts. Is it even possible? And so a bit of this building was a thesis of like trying to prove that out. How far can we go? And so we experimented with a lot of new materials. I think we had 5 first generation low carbon concretes that we brought into the project that whether it was coming from the University of Washington or from MIT or from UC Berkeley, we were like literally working with professors, taking what they were doing in the laboratories and doing first trial batches on this project, doing like truck trials, and whether it's slab on grades or foundations, using these materials in some responsible risk managed ways to show what's possible.
Wow, was it hard to find partners who were willing to run these kind of experiments with you?
Let's just say I abused my position in the industry to get contractors and material suppliers to do things that they may not normally want or wouldn't do. But in the spirit of it's a small scale project that we could do a risk managed trial. And I, as the owner, was willing to take the liability of proving these out, what to use. And I was also the one paying for it. So they came on board. It was amazing, though, how much industry support I found and saw. People want to try these things. They want to find the opportunities and how to use them. It's just finding the right opportunities where people are willing to step out and do that. And one of my biggest lessons from Hubbard's Corner, all these new materials that we used and we procured and brought in the project, that was not the risk. That's not the developer's risk. The risk of schedules for permitting, utility permits, water permits, electrical permits, all these other normal developer topics that need to be managed and dealt with on a very regular basis were much, much harder to work through than a truck trial of a new type of novel concrete that we could get industry motivated to help bring best of class uh, people to the table to help us go place.
I guess aside from that learning, was there anything else that has emerged through this experiment?
Using the low carbon concretes certainly was one of the most novel steps that we did on Hubbard's Corner. But those truck trials and that experimentation actually has led to part of another effort that I was working on through the Climate Works Foundation, where we did a series of case studies of first generation material uses, not just in Seattle, but across the country. And I basically worked with and found developers willing to do a truck trial pour. They had a big project that they were doing, but to do a small pour on the side of a new next generation material compared to what they were doing for business as usual. And we did it in Chicago, we did it in St. Louis, we did it in Boston, we did it in Los Angeles. So we picked different places across the country and worked with local suppliers to show how we could take some of these same ideas that we were doing on our Hubbard's Corner and use it on a bigger scale. Created a wonderful task force, blue ribbon task force of individuals that helped consult on each of these case studies. But we did the case studies, we wrote them all up, and we put them all out into the web for public consumption through this lower carbon concrete task force website that we created. And we not only did the case studies, but we also then wrote a guide, a best practice guide of how to ask the questions and how to use these materials to responsibly bring them forward.
Can you share that website?
Sure. So it's at lowercarbonconcrete.org, but the guide that we put out with that really is about how do we walk before we run? And these truck trials really were part of that. Before we go from a novel material to production ready for scale on a big project, there's steps that we need to go through to get testing data to responsibly understand what we're doing. These case studies and truck trials, like our small Hubbard's Corner project, is really just one of those stepping stones. And so what we did with this guide was try to put that all into one place and help explain kind of best of practice, where's industry on this topic and where can it go?
So how long does a novel material like a concrete have to be, I guess, in place, or how long is that testing period before it can potentially scale?
Oh, good. That's a really good question. It doesn't have a simple answer. What what I found out of this is while it will take years of development for material scientists to come up with like maybe a new novel binder for a new type of cement, um, it's going to probably be a couple more years of truck trials and processes to get it into production. But the challenge here really isn't a material science problem. It's really a scale problem. When we talk about concrete, we just use so much of it. And there's just an explosion of new ideas and material science work happening today in the concrete world. That's a really exciting time because there's all these new lower carbon alternatives coming into the market. But the problem is really a scale problem of which of these ideas can we actually scale up to the volume of what we actually consume in the US. In the US right now, we use, I think it's around 120 million metric tons of cement every single year. And so just how do we get from a couple thousand-pound truck trial to tens of thousands of pounds to millions of pounds to tens and hundreds of millions of pounds of material? That's a major scaling problem. That's almost a bigger challenge than the material science. And that the money and capital available to scale, that's really the challenge at how fast these materials can come into the market.
Interesting. And I know last time we spoke too, you mentioned that the concrete, I think around the exterior, the sidewalks of Hubbard's Corner was actually more carbon intensive than what went into the actual building per
This
code. Or something.
this was another lesson learned out of our Hubbard's Corner project where we tried to measure everything. And answering part of that question, what do we not even measure today? What do we don't know? One of the things I discovered was that the concrete we put into the site work for the sidewalk for the roadway, which required using some City of Seattle mixes that were good mixes, but were, let's call it business as usual compared to the novel new materials I was putting on the inside of my building. That just the sidewalk site work concrete was a larger carbon footprint than all of the concrete that went into the inside of my building for the entire project. That was a huge eye opener, because usually when we're measuring our buildings and reporting carbon footprints today, we don't measure the site work. We just measure the drip line of the building and what happens in the building. Maybe we should be adding everything in. So this is one of those thoughts of what are we not even measuring today? And it's a bit of a caution of, we can't jump too fast to declare victory before we've actually tried to totally understand the problem that we're trying to tackle.
Yeah, that's really interesting. And it sounds like, too, perhaps some of the maybe some of the code language or something needs to change as well, so it addresses those things like the sidewalks.
Yes, but it also takes curiosity. It takes people kind of wanting to ask the question, how do we challenge business as usual? And what questions are we not asking, to then go find answers to those? Let that inform our then code and building processes to make more informed choices along the way.
I like that. Start with curiosity. What other kinds of materials did you use in Hubbard's Corner aside from
Yeah.
those novel concretes?
So we used a lot of fancy concrete. Okay, I'm a structural engineer, and this was an adaptive reuse project. So the lateral system that we had to put into the building was a bit of fun sport. I used the low zero Portland cement concrete in the basement shear walls and foundations. But on top of that, I put steel braced frames in the same line on top of the concrete walls that used salvage recycled steel, sourced in a way that didn't require going to the mill to get new material. And then on top of that steel brace frame for the second floor, I used a first generation mass plywood shear wall. And so actually in the stack, wood to steel to concrete, I used like a next generation best of lower carbon class solution and put that all into the same stack. So that was kind of a fun uh, trick of parts. But we also used CMU blocks in the building that were grown from algae, which was a product coming out of UC Boulder originally, but Prometheus materials. So that was again one of these first generation solutions. All the insulation in the building, where it was not exposed to water, we used hemp wool insulation. Company coming out of southern Idaho, and bringing in a bio-based material wherever we could with a very low to negative carbon footprint as far as we could possibly get it.
How did you find some of these first generation products?
I'd like to say go to Building Transparency and look in the EC3 database and look at who has EPDs for new materials as a starting point, or go to places like the Carbon Leadership Forum and just be a student of who's doing what of new materials, and you'll find wonderful resources in those places. Frankly, it also came from 10 to 15 years of just being in the industry in this space and trying to understand who was doing what. And then so I probably had a lot of prior knowledge of places we could go in some of these spaces. But Carbon Leadership Forum, Mindful Materials, ILFI, International Living Futures Institute, each of these organizations have really strong forums, collections of people trying to work on lower carbon building solutions, lower carbon building innovations, and making those new materials available. Engage, get involved, ask questions, and you just find these things just through the networks. That's at least where I started.
So I guess moral of the story is get curious.
Yes, for sure.
With some of these novel materials or first generation, do you run into any issues with inspectors or passing code or anything like that?
Absolutely. In fact, let me talk about the low carbon concrete that we put into Hubbard's Corner. The biggest thing I want to say on that is we didn't cut corners. We didn't try to do an end around or circumvent the testing. What needs to happen is go do the testing, get the information to allow you to make more informed decisions. And if you're doing it the right way, many of these materials you will find actually are approved for use if within the building code today, but you just have to follow the right rules with that. The other part is bring people along, no surprises. So in our case of the low carbon concrete, we did batch plant testing and trials before we actually put it into place on our project. We submitted the mixed designs through the city of Seattle. We went and had meetings with the city to let them understand what we were doing so there was no surprises and to show them how we were responsibly using these materials in ways that they met both the letter of the code and the intent of the code. So now, one of the reasons to test on only a small 2-story building is I'm actually not pushing the concrete strengths that hard. So where I only needed 3,000 to 4,000 psi concrete, and we were getting 5,000 to 7,000 psi concrete strengths, it made it easier for the building officials to say, well, I'll accept it in that location for that mixed design, and providing the backup test data before we actually put it into use. So we didn't fly blind, and we actually did not try to cut corners at all.
What's next for Hubbard's Corner and with this knowledge that you've gained from these experiments?
So Hubbard's Corner, like I said, we measured everything. I've actually kind of curated and packaged up all the quantity and the carbon data as we have for that project. And then I've given it to the University of Washington to let it be information for students to work with. It's the size of a project people can get their arms around it. And it was fascinating shortly after Hubbard going over to one of the poster sessions from the architecture department and to see 3 or 4 posters of our building where students were studying different parts of the building, using it as kind of a learning opportunity of how to use new low carbon materials, what might those mean into the building. So that's part of it. It's education and outreach. And frankly, taking these lessons learned and reapplying them. On other projects, helping other people do the same thing, growing and scaling this. I find myself through building transparency with a lot of touch points with a lot of really large tech companies that frankly are doing in many ways some of the same things we did on Hubbard, but on really, really large scales, where it's not a small 5,000 square foot adaptive reuse building. It's a data center. And it's not just one data center, it's 10 data centers. And so a lot of this experimentation and these ideas are scaling up and are being used by especially the tech companies right now looking to try to innovate, to try to find out how can they disruptively help move this market along to lower carbon solutions and bring those into the market to allow them to scale. So it's acceleration and more of the same, just at a bigger volumes.
That's fantastic. You're educating the next generation, but also being able to put those learnings into practice now with these tech companies that are building.
It's a fun journey. It's never dull for sure. It's very entertaining. But it's also it is a collective action effort. For the efforts that I'm doing, there is a passionate group of people that are also in the same way in the architecture, in the engineering, in the owner spaces that are all trying to work on this problem. Because frankly, climate change is a global problem. It's a problem that's bigger than any one of us. And maybe this is what kind of brings it back around to. It's all working on different parts of trying to solve this bigger problem that we're all part of. And there's only one planet here. So we really don't have a choice. We can't afford to not get it right.
Given that carbon is, of course, a global problem, and then it's the responsibility of everyone to kind of take action. I guess with even the best intentioned uh, carbon reduction strategies or projects, what causes them to stall or fail?
There's a couple of reasons that things stall out, but the biggest one is we simply have to have the motivation to act, and people need to feel that it they can manage the risk of what it is. People often will not act because they're fearful that if they do it, what if it goes wrong? And so it's really, really important that owners set a table where they will allow for managed risk and uh, trying things out, coupled with incentives that motivate people to want to do these things, and then someone with just kind of the passion and the will to lean into the problem, to be curious, to want to help solve a problem and to innovate and try something new. I really like, as an example in that, Skanska as a company. We talked about earlier about building transparency in EC3. Skanska has it as an ethos. Every project is an opportunity to do something. Every project has to do something new and innovative. They don't tell the project managers what they have to do, but they have to do something. And then be able to say, what did we do on this project that's never been done before, that's new, something that moves the industry forward? And I think just that mindset is so important to how do we create this innovation? How do we create action on carbon? Because people need to get out of the rut of just business as usual, doing what they've always done. Try something new, but do it in a responsible way that actually creates innovation and moves us forward.
That's great that it's baked into the culture there. And yeah, like you said, what a great mindset to approach projects with. One last question, just to circle back to building transparency in EC3. What's next for EC3?
Yeah. So EC3, it was a wonderful start, but it's not a static tool is probably an important thing people to know. I think we've added like over 15,000 EPDs just in the first half of this year. But we're currently moving from those teenage years to the adult years I mentioned earlier. We're 5 years smarter than when we started. We're going to create EC3 2.0. And we actually have a coalition of our technical partners that are coming together that are going to help us the funding of this to create a next version of the tool. And it's not necessarily more bells and whistles. It's actually simplification, but make the data even more accessible, make it easier to get to the information, make it easier to use so that people understand information and are willing to use it in their decision procurement buying processes, which is really what EPDs are about. So EC3 2.0 is going to be a 2026 project and a really exciting part of building transparency's next chapter.
That is exciting. Can't wait to see what emerges. I guess one last question.
Mhm.
What parting words of wisdom would you have for fellow structural engineers who may be wanting to get started in carbon reduction but maybe don't know where to start?
Starts with being curious. Don't accept no for an answer. Actually lean in to what you do. And it starts with quantities. I got into embodied carbon is another way to tell an optimization value story to our clients. Use less materials, use them smarter to save a buck. Changing the variable from dollars to carbon, it's the exact same timeless conversation. And so for engineers, it starts with don't be lazy, don't be sloppy, lean into your problems, be a perfectionist of your craft of engineering, using materials wisely, measure your quantities, understand the quantities, and then help that inform your decision process. That will totally lead you hand in hand to carbon optimization. Because if you're smarter with your quantities, you're using less material, the next step of, okay, where do the materials come from? It's just another extension of that same focus when you're looking at carbon. And find other fellow engineers that are working on the same problem. The SE 2050 working group is a fabulous collection of engineers coming together that are all, frankly, trying to solve the same problem in their respective firms and work on the same problem together.